At first, I will give you short information about ComeMit, and then I will invite Mr. Gorji, our great speaker today, to start the presentation. ComeMit is a German-based startup, and our main vision at ComeMit is engaging and returning employees with the power of data. So we have a people analytics management tool, and it's about 3 years that we are active in Germany's market. And now it's about 5 months that we have launched and founded ComeMit Academy, and our main vision in ComeMit Academy is providing the possibility of live interactive courses, workshops, and webinars for those who are interested in different technology areas. That means all of our trainings and workshops are live and interactive. We have different kind of project-based training. We have different guest speaker sessions, and based on our target market, all of our trainings and workshops are in English and Persian. And these are now our current programs at ComeMit Academy. We have data science and machine learning course. We have data visualization in R, people analytics, Power BI, and also we have a great workshop for those who want to start the startup in Germany, because you know that founding a startup is always complicated, but in Germany, I have to say it's really complex because you have to do a lot of paperwork. And by these workshops and these courses, we have provided the possibility of having interaction with great experts in different fields of technology. And these are our communication channels. You can visit our website at ComeMit.com and also ComeMit.com/academy if you want to understand about our current programs. You can send us an email in academy@ComeMit.com, and you can follow us on different social medias. We are active on LinkedIn, Twitter, Instagram, and Facebook. And I'm really happy that you could join us today. Our great speaker today is Dr. Gorji. He's a senior data scientist at IBM. And now I have the pleasure of inviting Dr. Gorji to start his presentation.
Hello everyone. Is it my screen is shared? Fatima?
Yes, it's shared.
Hello everyone. Thank you very much for joining this webinar. Today I'm gonna explain and share with you some of the basic concepts of the working with graph data in Python and some use cases that I have conducted in my career as a data scientist. This webinar has some parts. First of all, I explain a little about AI ladder, and then explain about the basics of and definition of the graph theory, then how we're gonna use the graph in Python environment, and then we move to graph database. And finally, we explain and go through a use case of graph database for customer journey modeling in marketing domain. First, let's go through the concept of AI ladder. So any data science project, the first step is start with business understanding and data understanding. These are the two steps that come together. First of all, we have to define a problem, and then we have to see what data we are available, and then we might go back and forward. We might say that, okay, there are some gaps in the data, or change the business definition of the problem because of the lack of data. And then our job as a data scientist starts from here, where we have to go through some steps. These steps, so there are some different interpretations for this step, but IBM Cloud has defined the steps in the form of AI ladder. That start with collecting the data, means that make the data accessible for the data scientists with the required security and access, the necessary access levels. Then organizing the data means that we should have a kind of catalog such that we can store the data there, and data scientists of different projects can easily access the data. Then the main task of our data scientists start that we analyze the data using machine learning and a statistical approach, but at the same time, we need to take care of the trust and explainability, which is another subject by itself. Then our model should be infused, should be operationalized through the business, and finally, the modernize of the AI system, AI model means that we should be able to move the data, our model to different cloud environment, so accessible by different sections of the organization. So these concepts of AI ladder are available in IBM Cloud and IBM Cloud Pack for Data. So here I just wanted to go very fast about how can set up an IBM Cloud account, how to start writing the code there. I mean, a Python or R code or Spark. First of all, creating an account in IBM Cloud is free, and you do not need to enter any credit card information. The only thing you need to have is just an email. For example, here I have created an account with my Yahoo email here, and then when you create an account, you open the main page of cloud.ibm. Here you have to assign the resources for your project. The main resource that we need for writing code is called Watson Studio. So from the top right, we clicked on create resource, and then we have this in this page of Watson Studio, and this is a page that we have different IBM cloud products. The Watson Studio is by itself included, is free. We can select the Watson Studio and initial this Watson Studio. Here, then we have to select the right plan. You can start with the free plan here, and then put a name for your service of Watson Studio. I type Watson Studio ComeMit, and then create. Now your session of Watson Studio is ready. You can just click on Get Started and open the Watson Studio environment, which is here. Then next step is creating a project. So IBM Cloud is based on the concept of project. A project contains of the assets, I mean data, codes, and people, I mean collaborators. Means that you can create a project and assign multiple people at different level of access to the project. Some of them might be admins, some of them just viewer. So I click on new project, and the next we have two options: create an empty project or upload a project from a file. If I click on empty project, I will have in this window where I can put the project information, the name. So one step remains here after putting the project information, where I have to assign a storage service to my project. If I click the add here, a new window opens where I can select the cloud object or storage plan. I can start with the free one and put a name there, and then create this cloud storage. Next, I can click on create and finish setting up my project, my empty project. After creating the project, we will have in this environment where the main environment of Watson Studio, then it can start writing the code. Before every step, we might need to add some data. So if I click on data, there will be a window that we can easily upload our data. And then if we click on notebook, we can create a Jupyter notebook in Python or R environment. And the other steps here, if you are like, you can explore, for example, the natural language processing or auto AI experiment, which is auto AI is a kind of model builder without using any code. That's something that is great to explore if you are interested. So here we can create a notebook and use different environment like Python, R, Spark, and so you can start writing the code here. If you are in the school, if you are a student, I suggest you to take a look at ibm.com academic and register with your academic email. So you will have access to many free resources, including Watson Studio and IBM Decision Optimization Toolbox. That might be useful for your project in the school and even your learning journey toward being a data scientist. So let's go back to the graphs. So many of us, almost all of us have heard the name of graph or network. So let's review the concept. First of all, the graph was invented, the concept of graph invented by Euler 300 years back when he was trying to solve a problem. The problem was that given 7 bridges on the river, he was trying to figure out, is there any way that we cross all of the bridges without doubling back? So when he modeled this problem in a mathematical format, he found that we need a kind of theory that today is very mature and call it graph theory. Finally, he found that there is no solution for this problem, but fortunately, for many graph problems, there are solutions. A graph consists of 2 parts, nodes and edges. Nodes are entities that we might define them based on our problem, and edges are kind of relationship between the nodes. Today, graph theory is being used in many domains, like for example in Facebook and Twitter. So each person in the Facebook, when you are friend with another person, you are in fact 2 nodes that are connected to each other by an edge of friendship. Google used kind of graph theory for ranking the pages when in the search engine, or for example in Google Map when you are trying to find your path from one city to another city. In fact, the engine behind the Google Map is using graph theory, because you have to find the path between the node A, your location, node B, the target location. And also for designing the microchips and ICs and many other domains, the graph theory is being used today. But the subject of this presentation about using graph theory, find graph data structure for our day-to-day data science jobs. And many of the data that we have access as a data scientist might be useful to analyze them not by kind of graph data structure. Let's review some of the basic concept of the graph. For example, in general we have 2 types of graph, directed and undirected. And I shown here that the directed graph, there are direction on the edges, and undirected there is no direction. For example, in the Facebook, when you are friend with someone, so that's the kind of double connection. So that would be an undirect graph. But on the other hand, when in Twitter you follow, or Instagram you follow someone, that's a directed graph. The distance of 2 nodes in a graph would be a small number of edges you need to pass to reach the destination. And you can imagine that that's the concept that's very important for Google Map, right? When you are looking for the shortest path to reach your destination. Centrally measure is looking to find the node, find that how important a node is in a graph. For example, here, this node has 4 connections in it, where the centrally measure is 4. If you want to normalize, we can divide it by over 5 minus 1, which is maximum number of edges. And the connected component is kind of portions of the separate part of a graph, where there is a path between any 2 nodes in each portion. For example, this graph has 2 connected components, where there is not any path from this node to this node. So let's start with setting up graph data structure in Python. For this goal, we use NetworkX package, which is a package that you can load in IBM Cloud, and even your computer you can install with pip install NetworkX. And it's very easy to use this toolbox and has a good documentation. And there are many resources on Stack Overflow here or there. So Network X is the setting up the network is simple. First, you load a package and set a graph or directed graph. Then you start adding nodes and edges. Here, for the object of graph, I have created one node, node 1 and node 2, and each node has a properties. For example, the properties here is title, John and Mary, and then I create a relationship between these two nodes, which is a marriage, right? So now we have a graph, and the next step is analyze this graph or get information from it. Let's go back to the IBM Watson Studio, and I have a simple code that going through to show how to use Network X for modeling a data. So I have downloaded data from Stanford repository for graph data, Snap. So this is a Facebook page-to-page relationships, right? So we have this table is that has two columns, ID1 and ID2, and ID1 is the first page and ID2 is the second page that they are connected to each other. And the second table we have the information of ID1 and ID2, right? So I have loaded these two tables to IBM Cloud, and then created network, NX graph Facebook, and I've defined a function that using using column of ID and column of page name, we create the nodes, right? So after running this piece of code, we will have all of our nodes in the graph. The second step, we have to create edges. Again, we find the ID1 and ID2, the entries of our tables, and create an edge between them, right? A graph add edge. At the end of this step, we have our graph. For example, this graph had 22,000 nodes and 170,000 edges. And the average JVM means average number of connection per page is 15, right? So then we can start exploring the data. We can find, for example, what is the name of the node number 45, right? And what is the ID of the page called IBM Live? We can find the edges that connected to IBM Live, which is these two edges, right? 3061 and 4898. We can find the degree centrality of each node, right? And sketch a graph, and then find the top centrality degree of the edges, right? For example, these 5 nodes has the highest centrality degree. Let's review the latest one, 168095, which is the name is US Army, right? Then we can find all of the paths of 168095 to another node, for example, 1387, right? We can have 3 paths between these two nodes, where one of the paths, the length is 259 edges and more, right? So here we can, this way we can find the path between nodes. We can extract some subgraphs. First of all, I have checked the number of connected components of this graph, which is 1. Means that this is a completely connected graph. There is no separate partitions. Now let's separate a subgraph. The ego graph is a portion of the graph that's connected to a node. For example, the ego graph of our main graph of the node 168095 with a radius of 2 means that any node that is connected by distance of 2 is distance of the two, right? Okay, I have zoom in the code. And then when we separated this subgraph, we can start some clustering on the subgraph. For example, we want to find between these 14,000 of the node, what are the sections that are highly connected to each other, right? This is fine using the community community comment, right? For example, here we find 10 subgraph, right? And we can visualize these 10 subgraphs in this section. Imagine that this can be useful, for example, if you have your Facebook data, you can group your Facebook friend with some groups, right? Some sections. Some of them might be different countries or different skills or blah blah blah. And for each one of these partitions, I have gone through a loop that try to sketch the word cloud of the title of the pages. Between these 10 pages, 10 clusters, it seems that each cluster has some meaning. For example, this cluster is mostly about US Embassy, this is about Canada Embassy, this is about NASA, and blah blah. Right? So it means that our clusters has some physical or in fact business meaning. So different type of graph theory concept might be useful for different problems. Here, I have a use case here that I have done. So we were working on a client that has a database of customer record, right? The number of records were 800,000, right? It was a large database, and each row of the database of the table had the first and last name of the client, of the person, the shipping and billing information, phone number, and email address. So these are the rows of the contact information for the clients of the company X, which is a medical company, right? And the goal was to find duplicates, entries in this database, because when they wanted to do marketing, they want to do marketing just once to a person. They don't want to send 10 email or a phone call to a person, right? So what we do is that first, for the first and last name and shipping address, we use some kind of matching. Means that we compare the text, and if the texts are very similar, right, we assume that these two rows are connected to each other. And the same for email and phone number, we use exact matching. And after this step, we will have a set of thousands of tuples in this format. For example, this tuple showing that 100 and 210, these two rows are connected to each other, means that there is a match between either the name or phone number or blah blah between these two rows, right? So we found this matching, but that's not the last step, because at the end we want to find the groups between these people, right? So that's the next step that we can use. We have used the graph theory. It means that using these tuples, we set up a graph like this format, and in this graph we have separated the connected components. Here, for example, we have two connected components, means that the contact of row 9,000, 100, 70,000, and 210 are connected to each other, right? There is no connection between 9,000 and 210, means that there is no common first name or shipping address phone number between these two rows, but there is a path between them. Then this connected component, each one of them is representing a person, and then the company could use each connected component as for a one marketing target. So Network X has many pros and cons. For example, you can easily use it in a different cloud environment, in Linux, Windows, and has a good documentation if you want to use it, and you can find many resources. But on the other hand, it's not very suitable for large-scale problems. And if you want to use some kind of parallel processing or something like that, that's not a good option. Also, the visualization is not interactive. If you've seen that in the notebook, we were just showing a graph. You cannot click on the graph and see some information. There are other options for graph analysis used in Python. iGraph and GraphTool are in Python environment. They have some pros and cons between, compared to Python. You can feel free to check. And Cytoscape, Gephi, and Graphies are mostly focused on the visualization of graphs. And one famous toolbox is Graphics in part of Spark environment, which is fast, but only has Scala API, no Python API, and as far as I know, it doesn't have visualization environment. So next, based on these concepts, based on these pros and cons, we are looking for better solution for large scale problems, right? Before going forward, for a short break, I'd like to have your feedback for the next step for the graph database. I would appreciate if you take a look at, if you open menti.com, enter this code, and see and provide me your feedback about whether you have experience with graph database or not. And I will show the statistics later. I typed the website and code number in the chat bar. Okay. The graph database. So many of us have worked with relational database or in fact SQL. So SQL is based on the tables. When we have a data, we store the data in different tables, right? For example, if we have some information about the employees and department, we store them in the two tables of person and department. And if we want to look, for example, if we want to find, for example, which persons are working in department 111, what we need to do is do kind of joining, left join, right join between the tables. And so this is a way that we use, many people use in databases, but not efficient if we have large tables and if we want to do multiple joins, right? So the computational complexity will go up. On the other hand, the graph database is based on the concept of the nodes and edges, right? A graph database, we have defined some edges, some nodes. For example, here we can define a node of type of person, and we find the node type of department. And then we define some edges. For example, the Alice belongs to the 3 department. Each node and each edge might have some labels. For example, the person node has a label of name, which is Alice, maybe another node like employee ID or date of birth, something like that. And each department has some labels, and the belongs to the relationship has kind of labeled by itself. For example, Alice belongs to department for future from 2019, right? That 2019 would be a feature or label of the edge. So in the graph database, we don't need to join, so because everything is connected by each other. But we need another kind of query language to extract data, which is different from SQL. The graph theory, instead of using merging and joining, graph database, instead of using merging and joining, use graph theory to extract data. If we want to go detail, the concept of graph traversal means that, for example, from one node, we go to neighborhood nodes and continue to this process until we reach all of the nodes, right? That's called graph traversal, which is a theory in graph literature. So that's the concept behind querying, right? So there are many options of the graph database, and feel free to explore any of them. Here I have shown an example from Neo4j. I want to explain about Neo4j, go through some examples in Neo4j. Neo4j is an open source graph database and very simple and easy to use. The data model, I mean, the way that we define the graph structure, nodes, edges, they are very flexible. And behind the scenes, using parallel computing, so it's very efficient for huge databases, huge graph, when you have millions of nodes and edges. It's secure and it is available in many cloud technologies like Azure, Google, and IBM, and that's what I have checked, and you might find in other cloud technologies. Neo4j has its query language called Cypher. Let me show some example here. Imagine that about this example I have shown in the previous slide, where we have two kind of entities, one person and one department. Person entity, we have a list, and department, we have 3 departments, right? We want to create nodes and edges for this graph. The Cypher use the command create to create the nodes. For example, I can say that for the name of type person, where the name is Alice, create a node, which is, this node is called P1. And the same for department, right? For the node type of department with the title of for future, create a department. And the same for the 2 other departments, right? At the end of this step, we have our nodes, right? We have 4 nodes. Then the next step is creating relationship. For this, we have to use the match command, match in core language. Match means try to find the nodes that matching our search. For example, match the person and department where the name is Alice and the department names are for future, P0 and A0, right? When you find the A, X, Y, and Z, which are the people and department, then create relationship between them. For example, create relationship between node A and X means that Alice belongs to the for future, where the year of joining is 2000. At the end of this step, we have our edges. Next step is getting the data, getting the result from the database. For example, we can use match persons that belongs to the department, and then return the name, the title, and year that they have joined. This command give me the table in this format, which is containing all of the information that I was looking for, right? So the Cypher query language, in general, it's shorter than SQL queries for a specific task, based on my experience. So this process, we can do it by ourselves, in Neo4j environment, but might not be efficient if we have data, right? For example, if you have a data of thousands of rows and thousands of entries, so we need a better way. We need that do it in Python or R. For this goal, we can use Python, which is an API for Neo4j. Python, we can write the code in Python environment and using a high-level API directly connect to Neo4j, add nodes and edges, and also run queries. For example, here, this is a simple code of Python. First of all, we define the graph. We define the node of type person where name is Alice. We define the department, and then create a relationship, right? Relationship between A and B, where the relationship type is belongs to, and the year of this relationship is 2017. So this line will create a relationship between the Alice and department A42. When we have our graph, then we can use graph.run and write our queries and get the data. This data will be in Python environment, and we can easily convert it to pandas and they start exploring and statistical analysis. So let's go to the Neo4j environment. So Neo4j you can download from neo4j.com and install the version in your computer. If in the cloud environment, you can also access IBM Cloud and Google Cloud, but they are not free because you have to set up a virtual machine there. But the first step, what you should do is that in this environment of Neo4j stuff, create a database, right, which I have created before. Here I have created a database of demo and set up a password here, right? And you can even add usernames, different usernames for the database. Then in the main Neo4j environment, I have created database, right? And you can write query here. For example, this query is giving us results. You can explore the data in an interactive way. For example, I want to find the companies I have. Like I have two companies, Apple and IBM. I will explain about this use case next. All right. For example, this IBM is connected to the two nodes, RSQL, and John is connected to two nodes, Work and Apple and SQL, and the same IBM to two nodes. So right, so it's interactive. It's not like different from networking where we just sketch a plot. We can explore the graph, right? And we can write a query here and explore the graph. But here I want to show an example of how I have created this graph here using Python. First of all, I have to load the Python, and there's another toolbox for Jupyter, which is useful for visualization in Jupyter Notebook environment. Here I have created data like in this format. So we have some trees. For example, John works at Apple and John knows Python. Mary works at IBM and Mary knows R, and IBM requires R or Apple requires SQL, right? So you can see that we have different type of entities here. We have entities like a person, we have entities like a company, we have entities like a skill or coding language. We have different type of relationship. For example, works, knows, and requires, right? So next step is define the data model, right? Based on this data, what I think is that we can create three type of nodes, like node of person, node of skill, node of company, and create three type of relationship, like requires, knows, and works. First of all, I connect using the right address to the graph database. You can use two options. You can use HTTP and Bolt and get the information of the database. Let me zoom in here. So next, I have created the nodes and edges here. I created node of type person and node of type company here, right? So there is one thing here I need to add, the primary key and primary labels. So imagine that you create a node of type of, for example, person, which name is John, right? So in this data, I can create a node of John and works Apple. Next time when I reach the John node, I have to be sure that for next time I don't create another extra node for John. Instead, I want to keep using the same node of John that I have created before, right? Because I want to create connect multiple edges to the John node. So that's the reason we use the primary key or primary label. Here I'm saying that the name is unique for the John, for the person, right? So next time if I run this code and we are getting the name of John, Neo4j and Python node detects that this is the same John that we had node before, right? So here, because of that, we have a merge, means that we merge the node to our database. If it doesn't exist, if it exists, don't create a new node. Just use the node that we had created before. The same for company. The name of company is the primary key for the company, and when we define the relationship between the person and the company. The same for type of nodes, where we have persons and skills, and the same for requires kind of relationship between company and skills. When we have this loop, right, at the end we can create a database by running this code, where they create a database on the three columns of node 1, node 2, and age, which is coming from this table, right? So next, we can draw our graph, which is here. As you can see that we have John, Mary, and Sarah, and we have companies, IBM and Apple. We have 3 skills and people, and everything is connected to each other. So we have our graph. Instead of having multiple tables, we have just a graph of 9 nodes with relationship. Next step is using Python to get information. For example, I can see that how many persons we have the data, right? You match person and count number of persons. Or find people, find the nodes where their name starts with J, which is the name John, node of John. Or finding relationship between companies, right? And so I find the company and the skills relationship. I think this I can remove from the code. And even we can write the query directly from here, right? For example, find a skill, find the people or persons, name A, where they work in a company, worked in a company. At the same time, the people that know Python as a skill, and return their name, return the skill name, and return the company name, which is return, and finally converted to data frame. So we return this query return 2 rows where the people who know Python and work in companies, IBM and Apple. We can also extract a subgraph, where here I find the people who work in a company, but instead of returning their name or company name, return the relationship, means R, right? That's it, and then convert to the subgraph. And this is the subgraph of our main. This is subgraph output of this query. So that would be this subgraph where Mary that works IBM, the people that works in IBM. So this is the simple example that how we can set up a graph database, how to connect to Python to the graph database, going through a loop, and add nodes and edges, write queries, and get the data. And as you see that we have the data in tons of data frames, so this data is ready for next step. I mean, a statistical or machine learning analysis by different methods. So now next step I want to explain about a use case that I have seen my career as in data science for modeling the customer journey using graph database. So the customer journey, in fact, is the process of the experience of the customer with the company, with the brand, right? If you are a customer of a bank, you might open an account, make a transaction, apply for a loan, or apply for a credit card. All of these are the journey of you with the bank. And this information, this journey is very valuable for the bank, because can use it for marketing information. And if you have a huge data of the customer journey of different people, you can use it for building recommendation engine or different type of analysis suitable for your business. Here we are talking about the customer journey for a home appliance manufacturer. So home appliance manufacturer has a website, and where people can go there and take a look at their product, like refrigerator or microwave and blah blah blah. So they didn't have the online sale, right? If you want to buy a refrigerator, you might take a look at the website, see the brands, see the models, and then go to a store, buy a product, and then come back and register your product, right? This is the customer journey. So you see that the customer might do some steps. For example, click an ad like in a website, or using search, or directly open the brand website, or use social media and visit several pages in the website, right? After some time, they might purchase a product, and again, after a while, maybe after 2 months, 3 months, maybe next day, they purchase the product. Usually, many times people don't purchase the register product immediately after purchase, because they only register when there is a problem with the product. For example, they want to use warranty. And home appliance data, or home appliance products, the sale is highly seasonal. If you open, for example, a home appliance website, if you look at refrigerator, you don't go to a store and buy it tomorrow, right? Because this is usually buy it, for example, when there's an offer, there's a holiday, or in the United States, people usually buy it in end of the fall, during Thanksgiving, where there is lots of cooking stuff happening in houses, and that's a rush time for home appliances. So we were trying to model this customer journey, right? For example, this customer journey is an example that a person use page search, open the home page, open the refrigerator page, and next time he use direct, check the where to buy page. Next time he use Bing and register, and then take a look at the microwave product. So imagine that if you have thousands of journey like this, that's a valuable information for marketing and building a recommendation engine. So the data source we had was from Mixpanel website. It's very similar to Google Analytics. It's that it install an applet in the website and track the user interaction with the website. For example, this and the data is in JSON format if you use the Mixpanel API. This is the example of the data where we have a distinct. When people open the website, the Mixpanel automatically assign a distinct ID to the people, right? Which is representing a person, a user. If you open the website after a month, if you haven't cleared your cache, or if you are using the same device, you will have the same distinct ID. And this person, this distinct ID, had viewed the page at this time, and the referrer is direct. He opened or she opened directly from the website using the Mac device and this browser and other information. So we had this data in this format where the event was the kind of activity that people had done. So then next step is defining data model. We defined 5 types of nodes where the user, store, product, manual, and page. A person might view a page from some referrer, like direct, and people might search where to buy, people might register a product and download a manual, right? So when we have defined this data model, then we go through the thousands of the, in fact, millions of the records of the JSON files we have, right? And read one by one and create a node and edges based on this data model. when we have this data model, when we have our huge graph, which has millions of nodes and edges, then next step is query, right? What type of information we want to extract. I'm showing some sample queries here. For example, we were interested to know how many of the people who bought the product had visited the website before the purchase date, right? We find the people who view the page and at the same time, or also they have registered a product where the date of the registering is less than the data of the viewing is less than data of the registration, right? And then find this number of these users. Or how many people had viewed the where to buy page, right? This was a hypothesis here that we were interested to know whether people had used where to buy page or not, which was very important for the manufacturer company, because where to buy page is page that you enter your zip code and find the nearest store to you, all right? So here, this query shows that find how many people, the users who search where to buy and find the number of them, right? If we divide this to total number of users who bought a product, we can find the percent of the people who used the where to buy page before purchase date. For this special use case, the percentage was small, right? And that means that where to buy page didn't have a high role in the sale of the company. And this query, this business question was important for building your conversion engine. Find the web pages that people who registered the product, who bought the product had viewed, right? For the people who registered the product, and what are the pages they have seen, right? And return the page title and the count of them, and descending by count, right? And finally, how many people from a city like Austin had viewed the page in 2017? Where I can here find the people who viewed the page and in Austin, and the date is 2017, right? So that was the example I have shown on the customer journey. I'm happy to answer your question if you have. You can ask your question or type in the chat section if you want.
For the grandparents. So if you have any questions, please ask your question.
Yeah, and even you can ask your question in the LinkedIn, the page of the product of the event, where I'm sharing some resources there about AI Ladder and Neo4j. You can take a look at those resources that I'm sharing there, and if you have a question that you want to, okay, yeah, I have a question here. I want to answer. Yeah, you can take a look at the resources in the LinkedIn page, and you download them if you are interested. About the MongoDB and NoSQL, so there is a difference between MongoDB and the graph database. In MongoDB, you are using kind of key values kind of a structure. Here you have relationship between nodes and edges, right? So if you want to do some data exploration, and definitely graph structure is more intuitive than NoSQL, right? NoSQL, you can use it for this use case, definitely, but the graph database is, I think, it's more intuitive and simple to use. compared to MongoDB, right? But there might be some use cases that MongoDB works better, for example, based on your data model. Maybe it's better than the graph database. But for this structure that we have, the graph database was working fine for us. The size of data set, I think, I don't remember the exact number, but the number of nodes and edge were in level of millions, because we had millions of people and that were visiting the website. But Neo4j, it was working fine, and the free version was working fine, and we can write the query and get the data.
Yes. Any questions? And as Dr. mentioned, we will share the resources on the LinkedIn page of the event, and also we will share the video of the event on YouTube and ComeMit channel. So if you want to watch again the information that Mr. Gorji today shared, you can also watch the video on YouTube.
Thank you very much for joining, and have a great day.